sketching polynomials, let's recap how we do that. So we know that the y-intercept is always the constant, because obviously when you sub in x equals 0, everything else disappears. So we use this as an example. Of course, we don't have to expand the whole thing out. We can just look at the constants. So 1 times minus 1 cubed times 2 squared is negative 4? Negative 4. Let's plot that. We know the x-intercepts are the roots, because this is factorised for us already, makes life easy. So we know we have one at negative 1, positive 1, and negative 2. As x approaches plus or minus infinity, so out of the extremities, a polynomial will always act like the leading term, because infinity is such a large number that just one more power makes all the other ones irrelevant. They're too small compared to the leading term. So in our example, the leading term would be x times x cubed times x squared, which is x to the power of 6. Now if we were to draw x to the power of 6, I know we would start up there and we would finish over there. So our graph will do that as well. Now the actual roots themselves, what power are those factors? If it's even, then it will touch like an even-powered polynomial, which is a U-shape. A parabola if it's power of 2, but obviously other even powers aren't parabolas, they're just a U-shape. So on ours, at negative 2, we know we have, well actually it will be a parabolic because it is power of 2. But if it starts up there, then I know it's coming through like that. Odd powers will do the classic horizontal inflection, just like the cubic. So it will look like that. So at positive 1, it'll inflect horizontally, but it's finishing up there, so it must go through like that. Well, there's the completion of the graph. Now, where it actually turns there, a bit of calculus would find that for us if we wanted to, because now we could find stationary points. We could work out where the horizontal tangent is, and that would tell us the x value of that turning point. Same with the other one there in between minus 1 and minus 2. Mind you, if they're just asking for a rough sketch or a sketch, we probably don't have to worry too much about that unless they've actually specified, find all turning points and classify them and that sort of thing. Okay, if you can factorise the polynomial down completely, so x minus a to the power of n, then it's one of our basic curves. All that's happening there is we've shifted at a units. Have a look at this one. X minus 1 to the power of 4, x plus 1 cubed, x plus 2 squared, x minus 2. Let's put it all together. There it is. So what do we got? We know the constant is 1 times 4 times negative 2. It's cutting at negative 8. X-intercepts at 1 minus 1 minus 2 plus 2. At 1, it's to the power of 4. So you see how it's got the U shape, but it's flatter than the parabola because the power is higher. Negative 1, we should have the cubic coming through. There it is. And at positive 2, it's linear. So it's coming through like a straight line. Which one have I forgotten? Oh, over here at negative 2, we should have a parabolic shape there. So there's our graph.